Okay, Assalamualaikum warahmatullahi and good day everyone. So I would like to do frame analysis, side sway frame analysis. Okay, as shown in the figure, so we are going to analyze using moment distribution method. Okay, so in moment distribution method, basically there are 4 steps. Okay, step number one. Step number one, determine distribution factor, Kn distribution factor. We calculate K in order to determine distribution factor. That is step number one. Step number two is no side sway. No side sway. Okay, step number 2 is no side sway frame. Okay, so under this step, there are 3 sub A, B, and C. Okay, 2A is FEM. We calculate due to external loading. External loading. Okay, B, from this FEM, we will calculate end moment. And this end moment for no side sway frame is labeled as M0, and after that we have to calculate restraining force. Restraining force, and this is R. This is step number 2. Step number 3 is side sway frame. Side sway frame, again A, B, and C. Okay, A is FEM, but this time this is due to side sway or delta. It is delta prime. Okay, then is end moment we call as M prime, and then restraining force we label as R prime. R prime. And step number 4, we want to calculate final end moment. Final end moment. Okay, let's say we label as MF. Okay, so M final is actually M naught, and M naught is end moment from table 1. Okay, we have to plus by R divided by R prime, the correction factor, times with M prime. M prime is end moment in table number 2. Okay, so this is from table 2. This is table number 1. Okay, so these are the 4 steps that we should do in order to analyze this frame. Okay, this frame, looking at this frame is unsymmetry. This frame is unsymmetry. So unsymmetry means the frame will tend to move sideway. This is unsymmetry. Okay, so this is sideway frame. This is sideway frame. So the end moment in this frame actually occur due to 2 condition. The end moment. Number 1 is due to external loading, and we have to plus with the side sway. Loading plus side sway. Okay. Back to the concept of principle of superposition. Principle of superposition. From principle of superposition, position. Okay, when we have, okay, let's say, okay, this is the frame. This is the frame. Okay, this frame, this is the original one. Okay, looking at this is unsymmetry. So this is side sway. This has delta, and this also has external loading, combination of external loading and delta. Okay, we have to analyze under two main steps. And for the first step, it is called as non-sway frame or no side sway frame. So what is actually happened is, because when we want to calculate FEM due to external loading only, we have to change the frame condition from from we have to change the condition of frame from side sway frame to properly restrained frame by putting one pin support. So by putting pin support at C, okay, by putting pin support at C, the frame is now become properly restrained frame, and properly restrained frame means there is no side sway. Properly restrained frame means we have removed the delta. We have removed delta because inside this, okay, we have number one, external loading. External loading. And number two, we also have side sway because it is unsymmetry. Unsymmetry. Okay, because it is unsymmetry, so there will be side sway. And due to these two reasons, external loading and delta, we have FEM. We calculate from external loading, and we can also calculate FEM due to delta, due to side sway. Okay, that is the idea why we have two tables. One is table for external loading, and another one is table for delta. The table for delta, and we have to separate these two tables. We cannot combine. Okay, in order to calculate FEM due to delta or due to external loading only. In order to calculate FEM due to external loading only, we have to remove delta. How to remove delta? We have to make the frame from side sway frame from original to properly restrained frame. And what does it mean? Properly restrained frame means there is a restraining force, okay, at C. So by putting pin support at point C, the frame is properly restrained. There is no side movement. So that we can calculate FEM using external loading only, because there is no more delta. Okay. So like this. Okay, and R here, this R is actually the reaction. At pin support, but we only count the restraining force, the horizontal reaction, because the frame move sideway, move horizontally, so we have to put R horizontally. Okay. And by comparing these two, we will find that diagram A is not equivalent to B. So what we need to do is we have to apply another one, so that when B plus C, so we can neutralize the R. So here is the loading. Okay, like this. So in order to neutralize the R, we have to add another frame. Okay, another frame. And we have to apply R in opposite direction. In opposite direction. So that this will become positive R. This is negative R. This is positive R. Negative R and positive R become 0. 0. Equivalent to 0 at original condition of frame. Okay, so this is what we call as principle of superposition. Principle of superposition. So in diagram B, we will calculate FEM due to W. Due to W external loading only, and due to R in diagram C, due to R, there's no UDL here, because if this is 30, okay, if this is 30, this is 30, 30 plus 0, we get 30. 30 plus 30 is equal to 0 plus 30 is equal to 30 plus 0. 30 equal to this 30 plus 0. So that we get 30. So same goes to R. This one is 0 plus 0 is equal to negative R plus positive R. So we get back 0. Okay, so this one is called as principle of superposition, where diagram C is actually is actually side sway frame due to delta. Side sway frame, it is due to delta. Okay, due to delta. This is delta, this is delta. So now we have combined back. So one external loading in this case is W, side sway is delta. Okay, so due to external loading, it is inside diagram B. And due to delta, it is inside diagram C. So this is principle of superposition. Principle of superposition. So that is the idea. Anyway, if in diagram B, FEM, we can calculate the value because W is given. W is 30 kilonewton per meter. But delta is unknown. But delta in diagram C is unknown. So when delta in diagram C is unknown, that is the reason why we cannot combine FEM in one table. We have to do it separately separately, means that we have to calculate FEM due to external loading only, and then we calculate end moment, and after that we will calculate FEM due to delta. But for diagram C, we will actually assume FEM, not we cannot, because we cannot calculate FEM because the delta n is unknown, so we will assume FEM. Okay, that is actually the process of principle of superposition. Okay, the idea. Okay, so we will start with uh okay, I skip the first step, K and distribution factor, because we will calculate the distribution factor directly in the table. We will focus on no side sway frame. No side sway frame, we actually focus on B diagram. No side sway frame, it is B diagram. So this is step 1. This is step 1. This is no side sway frame. Okay, this is table number 1. Okay, table number 1. Okay, so we will have 6 end moment. We have 6 end moment A, B here, A, B, B, A, B, C, C, B, C, D, and D, C. Okay, we have join A, join B, join C, and join D. Okay. Okay, we make a boundary between A, B, C, and D. This is for A. Okay, this is for B. This is for C. Okay. Okay, we will calculate K and distribution factor. Assume EI is constant. Okay, for AB, it is 6 meter and it is far and fixed here. So we use 4 for EI over 6. 4 EI over 6 because EI is constant. So it is 0.667. So here is 0.667, 0.667. Okay, for member BC, it is 4 EI over 5. 4 EI over 5 is 0.8. So this one is 0.8, 0.8. Okay, next is also far and fixed. So we use 4 for EI over 7. 4 EI over 7. Okay, 4 EI over 7 is equal to 4 divided by 7 is 0.571. 0. Here is 0.571, 0.571. Okay. Okay, now we continue distribution factor. Distribution factor for fixed N A0, fixed N D0. And then we calculate distribution factor for BA. For BA, it is 0.667 divided by total 0.667 plus 0.8. Okay, it is 0.455. 0.455. Okay, we minus by 1, we get another one equal to 0.545. Okay, for CB and CD, it is 0.8 divided by total. 0.8 plus 0.571. Okay, it is 0.584. 584. And another one must be 0.416 because total must be 1. Total must be 1. So this is distribution factor. Okay, now we will start FEM. Okay, FEM due to okay, external loading. Okay, back to the question. It is AB that is subjected to W. It is UDL, so we use WL squared over 12. W is 30, L 6, WL squared over 12. and it is 90. It is 90. Negative or positive? Negative or positive? If it is like this loading, so moment will act like this. So both is 90 and this is A. This is A, this is B. So A is negative. So the value is negative 90 and 90. Negative 90 and 90. The rest are 0. Okay, then we start with the first distribution. The first distribution, okay, the first distribution. So we will distribute joint moment. We will distribute joint moment, means that it is 90 times with factor, then times with this factor. Okay. Okay, it is 90 times 0.455. We get 40. We get negative. Because this is positive, so the answer must be negative. We have to change sign. Okay, so this is 40.95. 40.95. And another one is 90 times 0.545. It is for negative 49.05. Okay, and total these three value 90 minus 40.95 minus 49.05. It is 0. Okay. Okay, settle. There's no more value. So next is carry over. Next is carry over. Carry. Okay, next is carry over. Carry over, we have to carry the value. We have to cross the boundary. The value must cross boundary. The value must cross boundary. So this is the boundary. This is the boundary. This is the boundary. Okay, so 40.95 divided by 2. The factor is 0.5. All factor is 0.5 except and pin or roller. Okay, it is negative 20.475 and 49.05 divided by 5 divided by 2. It is 24. So this one is negative 24.525. Okay, then we have to repeat distribution process again. We have to repeat the value, repeat distribution, then carry over again, then distribution again, then carry over again until the last distribution. Okay, so okay, to work fast, I want to calculate the value in Excel. So we have A, B, B, A, B, C, C, B, C, D, D, C. Okay, distribution factor is 0, 0.455, 0.545, 0.584, 0.584, and 0.416. And it is actually 1 minus this one, 416. Okay, then 0. distribution factor. Okay, the FEM due to external loading. Okay, it is negative 90 and 90. Okay, start with distribution. Start with distribution. Okay, for joint B, it is 90 times with 0.455 and 90 times 0.545. Okay, these four value must equal to 0. Okay, there's no more value FEM, so we have to carry over the value. So for carry over, we have to divide by 2. Carry over, cross boundary, we divide by 2. Then distribution, again, okay, so we just need to distribute negative 24 here, 0.525 times with factor. This is occur at joint C now. So it is 24 times 0.584, and the answer must be positive because it is opposite condition. Negative 24 times with 0.416. Okay, and these three value must be 0. Must be 0. Okay, next is carry over, cross boundary, divide by 2 here, and this one divide by 2. Divide by 2. Okay, then we continue distribution. Okay, now we have to distribute 7.1. Okay, that is occur at joint B. So BA and BC. Okay, negative for opposite condition times with factor. Times with factor. Okay. No more? No more. Okay, carry over. Okay, now carry over. Then this one, carry over. Okay, for distribution. Okay, for distribution, we have to distribute. Okay, negative 1.9 times factor. Negative for opposite times factor. Okay. Carry over C to B divided by 2, and this is also divided by 2. Okay, next is distribution. Okay, we have to distribute joint moment at B, negative for opposite condition. Times with factor. Another one. Okay, no more. Carry over. We divide by 2. Cross boundary. Okay, distribution. Next distribution. CBCD. CBCD times with factor. Okay. Okay, so we may stop now. So this is M naught. So we have to total all the moment. Total. And this is the answer. Okay, so this is the answer. For table 1, this is M naught. Table number 1. Okay, so this is table number 1. So for table number 1, we have 6 end moment. We have 6 end moment. So if we draw AB, BC, and CD, okay, this value is actually negative 112. It is negative. This is 112.234. And then we have 45 positive. 45532. Here is UDL 30. Then another one is negative 45.532. Then negative 11.709. Then positive 11.709 and positive 5.507. Okay, now we have to move to step 2C to calculate restraining force. To calculate the restraining force. So how to calculate this restraining force? Of course, we have to refer to diagram B. We have to refer to diagram B. So in diagram B, okay, here we have to refer diagram B just now. Okay, R like this. This is UDL 30. Okay, and then we have to draw all horizontal forces inside the diagram, all horizontal. Okay, when we put these two direction for AX and DX, it is actually we can put in any direction that we like. If we want to calculate, put like this also okay. If we want to calculate like to put like this also okay. Okay. Okay, let's say we have this. Okay, so we have to write an equation relating R. So it is called as shear equation. Shear equation is total Fx is equal to 0. So this is Ax, this is Dx. Okay, so from this, we have to write equation based on total Fx 0 because our intention now is to calculate R. So R, we can calculate using the summation force, horizontal force in this diagram. So we write equation. So this is 30 plus Ax plus Dx minus R. This is equal to 0. So if you want to calculate R, it is actually 30 plus Ax plus Dx. So this is the equation that we made in order to calculate R value. Okay, so in order to calculate Ax and Dx, we use what we call as column analysis. Okay, so we consider column AB. AX. And it is 45.5. 6AX is negative. 532 minus 112.234 minus 30 times 6 times 3. We divide by 6. So at this step, we actually apply what we call aesthetic equilibrium in order to calculate AX and DX. 45.532. 45.532. We minus by 112.234. We minus by 30 times 6 times 3. 30 times 6 times 3. And the answer we divide by 6. So AX is negative 101.117. So we consider column CD. Consider column CD. So CD, X. Because we have always need to refer to this direction that we put when we write the shear equation. Okay, because this is the shear equation. And the moment is 11.709, positive, positive. The moment is positive, positive. Positive, positive. 11.079, 079 and 5507. Is 7 meter. So this time we have to take moment at C. So we can calculate dx. So it is 11.079 plus 5.507 minus 7 dx. So dx is equal to 11.079 plus 5.507. We divide by 7. It is 2.369 kilonewton. So we substitute into the shear equation. So shear equation R is equal to 30 plus AX plus DX. 30 plus AX plus DX. It is 30 plus AX is negative 101.117. Negative 101.117. And dx is 2.369. It is 30 minus 101.117 plus 0.369. So we get R is equal to negative 68.748 kilonewton. So this is step 2. Okay, we calculate FEM table and then we calculate R value. Okay, so this is for step number 1. No side sway frame analysis. This is table number 1. Okay, table number 1. So step number 2. Okay, for step number 2, it is side sway frame. Okay, this one we will continue in the next video. Okay.